Before we take a look at the approach to this question, it is very important for me to just tell you up front that for questions like this, you need to go and dig into everything you know about trigonometry. So you need to know how to work with a normal, opposite, adjacent, and hypotenuse sides from a normal rectangular triangle. You need to know how to work with your double angles. You need to know with your sine rule, your cos rule, and anything else that you have learned along the way, identity sometimes even. You need to work with that in questions like this. So when we take a look at the question itself, the sketch in this question, you need to also observe that this is a three-dimensional problem, a three-dimensional sketch. Even though that is flat on the screen right now or on a piece of paper, you need to be able to identify that triangle there, for instance. Just to start with. Look at that triangle as if it is physically lying on a piece of ground. Let's say on a rugby field, there is a triangle drawn out. That is what we've got there. Then we have got the other side of this figure, which is that part over there, the rectangle plus the triangle on top of it. So you've got the field, you've got the triangle, and then you've got a vertical wall or something like that, where there's a rectangle, and on top of the rectangle, there's another triangle drawn in the sketch. So you need to see that, the three dimensions. However, working with three-dimensional triangles or three-dimensional trigonometry, you can still isolate the various triangles or the various figures, working with them individually as if they were the only stuff you were given. So for instance, if you take a look at this question, just take a look at what we've got over there. There is a small b. Now if you go to the sketch, you'll notice that small b is given there as the length of a side of that triangle. So if you isolate that triangle, just look at it in isolation. No three-dimensional sketches, no real world scenarios, nothing. Just looking at that triangle, you can then work towards that side of the triangle. Then you take that information and you transfer it to that side over there. And then from there, you can transfer that information to the hypotenuse of that triangle that is over there. And that's exactly where you want to be, with that long side. You can literally take the shapes, even though it is in a three-dimensional context. You can take these shapes as if they were standalone triangles and rectangles or whatever the case might be, and then just work from one side to the other, transfer the information to the new sketch or the new shape, then from there and there and there, until you get to the point where you need to answer your question. So what you have to do in this case is, starting with that angle or that side B, you've got an alpha over there, you've got a beta over there. And you'll notice in your final formula, there is an alpha and there is a beta. There's also a theta, which is the angle over there, all given into this formula. So you will be working with variables only. There are no numbers there. You'll just work with the variables, sides and angles, and transfer from one shape to the other, to the other, to the other, until you get to that formula over there, which is then part one of this question. And then once you've got that, you'll just simply take those values that they give you over there for all the variables, substitute it into that formula, and then find the final value of the expression.